Hi, welcome everyone to the session 8. So, in this session, we will look at how to create a ML pipeline. The core objective of creating an ML pipeline is to streamline the whole process of data preparation, like encoding categorical features, data imputation, or data scaling or feature scaling, model building, and model deployment. So let's get started on how to create a ML pipeline. For this session, I have uploaded an worksheet to the session 8 folder of the GitHub. It's called ML underscore pipeline underscore worksheet underscore v1. And we will start that particular worksheet. So creating ML pipeline. We'll do exactly the same steps that we have done for model development and model deployment. The only difference is this time we will not do those steps separately one by one, but we will actually create an ML pipeline which will compose the steps of data preparation and model training, so that the whole pipeline we can take it to the inference system and deploy, so which can now be fed the raw data and which will automatically do the processing step required before making an inference or prediction. So for this, I have completed few steps like loading the data set, feature set selection, and so on and so forth. The remaining all steps of how to create a pipeline, we will do it together. Okay, so let's get started. We'll import the required libraries like pandas, numpy, matplotlib, and seaborn first. And let me restart the kernel to restart fresh. So let's import all the required libraries and import the data set, the final cars maruti.csv, and we can look at the samples. Again, the 1010 samples, about 11 columns. So one column is the outcome price and remaining are features. For this exercise, I have taken only a small subset of columns to just uh, show you how to create ML pipeline. But as an assignment and exercise, you can do it for the complete feature set. So for this, I have selected fuel type, transmission, owner type, age, model, and kilometer driven. Mostly the questions that typically the customers ask, the most important questions to ask, like how old the car is, how many kilometer driven, what model it is, petrol, diesel, automatic or transmission, first owner or second owner, and so on and so forth, right? The most important questions, 6 questions that typical people ask. Will utilize or leverage only those features to build the model. The accuracy of the model will be little lesser compared to the model that we built in the previous session, but that is fine. It's just to showcase how to create an ML pipeline. So let's set the X features. So X features set to all these 4 variables now. And out of that, as we know, these are the categorical features: fuel type, transmission, owner type, and the model. These are the 4 categorical features. And the remaining one, which is your age and kilometer driven, will be your numerical features. So let's set a variable, create a variable called cat underscore vas and set to the categorical feature names. And then we can subtract this subset from this complete set of features. So you can set X features minus set cat vars and convert that into a list, so which will automatically contain the name called age and kilometer driven. So the reason we define separately the cat features list and numerical features list, because it will go through a separate transformation step. For example, it will go through the transformation of one hot encoding, and numerical variables can also go to a set of transformation, though we are not doing any transformation in this particular notebook, but it may go through something like scaling, right, or some imputation and all that. First we'll set the x and y variables. So x equal to cars df dot features and y equal to price, and we will do the data splitting first. So again, we'll use int test split and use the variable in x and y and split the data into 80 and 20 ratio. So let's import this first. And as you've already seen, there are 808 in the training set and 202 in the test set. So now let's create a pipeline. So I have not done any encoding and all that before splitting, right? Because the pre-processing step of encoding and scaling will be part of the pipeline. We just split the raw data here, x and y, before doing any processing, right? The original data. And now we'll create a pipeline which will take care of all those steps. In the pipeline, the first step that we'll do is create a pipeline to transform the categorical feature into one-hot encoding, and numerical features will be as it is and no transformations will be required, right? So let's create a pipeline here first. And for pipeline creation, we cannot use pd get dummies anymore. We have to use the scikit-learn's the column transformer class. So it has a pre-processing class called, so from sklearn dot pre-processing. If you remember, there's a pre-processing module. Import, there's a one hot encoder, and we can initialize that one hot encoder equal to one hot encoder, and we can also give something like handle unknown categories. For example, let's say we have we've given one categorical feature called fuel type, right? And we know that the model, the data now currently contains a training set, let's say, contains only petrol and diesel. But let's say in production, somebody enters the data called electric vehicles, right? But we haven't learned anything from here, so those will be completely ignored. Only the input data that is there, that we have learned during the process of training, that will be leveraged. So once we create the one-hot encoder, we will not encode, we will include this as a part of the pipeline. So whenever we feed the data, automatically it will transform it. So to do that, we have to say from sklearn dot compose, there is a module called compose, import column transformer. So which will be required to specify how each column would be transformed. Each column or a set of columns would be transformed. Then from sklearn dot pipeline, import pipeline, and we'll create a pipeline to transform each subset and put that into a column transformer. So first, let's say create a pipeline to convert the categorical features. Let's call it a categorical transformer, let's say, and let's say we'll do a pipeline, and the pipeline will contain certain steps. In this case, of course, just one step, and let's call that OHE encoder, some name, and then we will provide this encoder pipeline. So all the categorical features will go through the one-hot encoding. That's what basically we are specifying. but it can actually contain multiple steps. For example, let's say there is a numerical feature there, and it has some data missing, right? So as part of the steps, we can specify that first you impute, the first step would be impute. It actually takes a list here. If you see here, you can say comma, first impute, and then you do a scaling, right? So first impute, then you can do the scaling. So whichever required steps and how many steps required, you can actually specify one by one here. So the feature, whichever feature we assign this pipeline to, that will go through the set of transformations. So in this case, as we already know that we only need categorical transformer, the numerical feature should be will not be transformed; they'll be used as it is. So now this is a pipeline. Now this pipeline has to be mapped to the categorical features now. So we can define the final preprocessor, which would look something like that, the column transformer. And we can specify, let's say, a transformer, the transformers, which are transformers. Here, the numerical, let's say I will just call it numerical. And my numerical features will go through, simply pass through. They will not go through any transformation. So numvars. So I have to give the list of transformations that each feature will go through, and let's say categorical, and this will go through cat transformer, the cat vars. So if you see here, here the final pre-processing step that we have specified, saying that my numerical features, this is just a name for the transformation, will not go through any transformation, simply pass through, but my categorical features will go through the cat transformer. Now the cat transformer is nothing but a set of steps. In this case, of course, just one step. And what is that step? That step is one-hot encoding. Okay, this is how the detailed steps are specified in the pre-processing steps. And then what we'll do is we will define the model. So if you see here, we have not applying the transformations yet, right? We'll define the model. Let's say we are going to use scikit-learn linear model, import linear regression, and then we'll initialize LREG linear regression. Okay. Now we are going to define the final pipeline. So let's say we call it LREG pipeline equal to pipeline, and the steps will be, so the model, the way the model will be built is, first we will do the pre-processing, preprocessor, and then the model will be built. Okay, so if you look at the LREG pipeline now, so this is a wonderful UI that's given here. So we are saying that whenever I give a data, raw data to the pipeline, first it has to go to the preprocessor, which will nothing but contain the steps that has to be applied to different variables or set of variables. So in this case, the categorical variables will go through the cat transformer, which is one-hot encoding, and the numerical variable will simply pass through. So if you look at this particular visualization, it tells you very clearly what's happening in the whole pipeline itself. So my variables age and kilometer driven will simply pass through and go to the model, but my categorical features, fuel type, transmission, owner type, and model, they will first go through the one hot encoder, which is again specified here. It's a one hot encoder, right? And the output of that encoder will now combine with this two numerical features which simply pass through, and then the linear regression would be applied. Okay, so now this whole pipeline can be used to train the model, and we can also carry this pipeline to the inference system. And when you give the raw data, again the raw data will go through this transformation automatically, and the model would be applied. So this is a wonderful way of creating a very streamlined process, steps of pre-processing and applying the model. Now, if you have to build a model, all you have to do now is basically say pipeline dot fit extreme and y-train. Okay, so this basically builds the model. Now, if you see my extreme, unlike my previous notebooks where we have seen, it contains the raw data. The raw data of, it's saying diesel manual first, right? We are not doing a PDK dummies encoding and giving the encoding variables, because we know that here it automatically gets encoded and model will be built. And in the LREC pipeline, now we can apply the LREC pipeline to the test data also, which again contains the raw data. So now I can just say LREC pipeline dot predict. Okay, so the fit and predict method is also defined on the pipeline. Okay. So it automatically understands what steps to be done. One of the important aspect called data leakage, which can be contained by using pipelines. But what is data leakage and all that, we will come back and little bit understand in the future session. But as of now, let's look at this simple step of applying the pipeline. So you can say predict x test, and we'll get the y-pred values here. And of course, you can also measure the metrics. So from sklearn dot metrics, we'll import mean squared error like we had done in the previous session, and R2 score, right? And let's say I'll just look at only R2 score as of now. So y test and y-pred. So it comes out to 0.87. Which is a little lesser than compared to the previous model we have built, because we have not taken all the variables. We have taken only the 6 most important variables. And now how to leverage this pipeline to predict on the new data. Now if you see, compared to the last session when we deployed the model, we had to give information like fuel type underscore diesel equal to 1, transmission underscore manual equal to 1. But here now we'll just give the input in the raw format, as if the user has given in the actual information required. So fuel type equal to diesel, transmission equal to manual, owner type is first, 8-year-old, it's a Ertiga model, and kilometer driven. Now how do I actually take this and apply to the pipeline? So first we'll create a data frame out of this. So pd dot data frame, because my data is expected to be in data frame. This is in a dictionary format or JSON input. You can say JSON input, data, and index is 0. I have to execute the step, and data df. If you look at this is the record that we got, and we have to make a prediction. So all you have to do is basically say LREC pipeline dot predict, right, on this particular data df, the raw data, and basically says that the car would be, the expected resale value of the car is about 6.17 lakhs. So this is a much more streamlined way of dealing with the raw data. So you don't have to do the processing step by step and then keep track of all those processings and then split the data and then build a model. You just specify the whole pipeline and give the raw data. We'll take care of the rest. And now what we can do is we just store the pipeline into the file. Okay, not the model, the whole pipeline, which can be now taken to the inference system and we can make a deployment, right? And the new user input will come in this particular format and simply will convert a data frame and invoke the pipeline to predict. So now how do I store it? You can say from job live dot from the import dump, because we want to dump the pipeline into the file. So you can simply say dump lreg pipeline now, and let's say give it a new name, cars model dot pkl. So this is going to store the whole pipeline into the file now, and you can see it has created the cars model pkl, little larger than the previous one, the previous model that we stored, but because it contains information like how to process the data as well. So that is this is the right approach to creating an ML pipeline. When we have found a model that is good enough for us to deploy, and then you can create a pipeline and simply take it, store into a file, the whole pipeline, and take it to the inference system for make deployment. And now what I'll do is in the future session, we will take this model and create an endpoint, like a RESTful endpoint, and invoke that endpoint with a user input, a JSON input over HTTP, and we'll see how to consume the model output from a model endpoint. Okay, so we'll use a Flask framework to do that. We'll also create a model app, a web UI, so that user inputs all this information on the UI, and then we will use this particular pipeline to make a prediction. So hopefully you understood the pipeline. This might look little more complex and confusing at the beginning, but once you get used to it, this is the wonderful way of developing and deploying models. So we will of course try multiple examples going forward, so we'll get familiar with the pipeline creation. So see you in the next session.